Okay, so kind of looks like I recorded the video and I didn't notice I was muted. So what we're gonna do? Let's see. Let me focus this in. Okay, so let's go over this pretty quickly. So, quiz 2.1 linear functions. So, what is my value of m? So, whenever you're thinking of m, we're in a linear function. M is my slope. It is my rise over run. It is my my delta y over delta x, which is my y2 minus y1 over x2 minus x1. And this is what we call our rate, average rate of change. They all mean the same thing. Average rate of change, slope, m, rise over run, delta y, delta x. They all mean the same thing. It's how does your graph change going left to right over your delta y, or your as you change y and up, or blah, blah, blah. How does your function change going up and down over how does your graph change going left to right? So this is your average rate of change. It's your slope, it's your m, and to find it, it's the exact same way for each one. So here, what is my value of m? Well, I need my delta x and delta y. And remember, delta x is your change in x's, delta y is your change in y's. So how do I find my x2 and y2 and x1 and y1? So when you're given a problem like this is going to be your inputs. Your inputs, or what you're plugging into the equation, right? What you're plugging in is going to be different x values. So we know these are going to be x values. This is going to be an x. This is going to be an x. How do I know which one is x1 and which one's x2? It's always going to be in increasing order. So x1, x2, blah, blah, blah. x1, which is -2, will always come before 4, right? And the number line, we're going to have -2, -1, 0, 1, 2, 3, and then 4. We have -2, and then we have 4. So we know we're going to label x1 as -2 and x2 as 4. If I plug in x1, if I plug in -2, whatever I get at the end, this is what I'm going to call my y1. We're going to keep the same numbers. Here, if I plug in x2, which is 4, I'm going to get out, I still don't know what the function is, but we're given the output. We're given the y value. We're going to call this y2, right? We're going to keep the same numbers. If I plug in x1, whatever I get, I'm going to call it y2. So plug in x2, get out y2. Plug in x1, get out y1. Okay, so if I plug this in, I get the corresponding y value. And to find this out, I just plug it in. So if I plug in my y1s and x1s and x2s and y2s into this, I'm going to get -1/3. Actually, let's go through it. So let's do m is going to be y2 minus y1. So y2 is 1, y1 it's going to be -3 or -3. Then x2 is going to be 4. And then minus x1, which is -2. So I'm going to get 1 minus 3, which is -2, over 4 minus double negative. So 4 plus 2. Simplifying, I get -1/3, right? And that's how we got -1/3. Okay, so now for the interesting part. Number 2, how do I write a linear function given 2 points? So to write the linear function, we need a couple of things. We need 2 points, and that's it. From these 2 points, I'm going to get a slope, or rate of change. I'll just put ROC. We just figured out how to do that. How did I find my slope? How did I find my rate of change? I look at the 2 points, these 2 points, and I calculate my m. Let's do that. And then after we find that, we're going to apply the point slope formula, which is y minus y naught is equal to m x minus x naught. All right, and this could be any point, any of the 2 points. Okay, so let's find our m. Actually, I'm gonna let you guys practice doing that, and I'm just going to say m is equal to -1/2. Okay, so double check that I got this correctly, that I got my slope correctly, given the 2 points here. So you can pause the video right now, calculate it, and make sure if this is correct. If I got it wrong for whatever reason, let me know, and you'll get some baguette or something. Okay, anyways, let's suppose we all got this. We all got -1/2. What do I do next? So we have our 2 points. We have our point -1 and then 3, right? And then the other point is going to be 3, 1. We're going to call this x1, y1, x2, y2. Okay, so then I'm going to pick one of these points. It does not matter which one, because we're going to double check with the other. So I'm going to go with this one. So I'm going to plug this into this using my slope. So I'm going to use y minus y naught, and when I'm talking y naught, it could be y1 or y2. I just need to stay consistent. If I use a y1, I need to use x1 when I plug in x naught. If I use y2, I need to use x2 when I plug in over here. So since I'm using this one, y1, and then I said my slope was -1/2 x minus x naught, which is -1. Okay, and now we just want to get it in slope form, or into a linear function. So simplifying, I get y minus 3 is equal to 1/2 x double negative plus 1. Distributing this -1/2, I get y 1/2 x minus 1 over 2. Bring this 3 over, I get y is equal to -1/2 x minus 1/2 plus 3. What is this? 1 plus 3. What is this? 6 over 2? I think so. Yeah. So then this is 5 over 2. So we have y is equal to -1/2 x plus 5 over 2. Okay? So that's what I claim my answer is. How do I double check this? So double check. If I use this one, I want to double check by plugging in my x value of my second point into this, and I should be getting the same y value. So if I plug in the other value, 1/2 3 plus 5/2, I should be getting 1 if I did my calculations correct. So this, you just multiply to the top, so we'll have 3/2 plus 5/2. Since they have the same denominator, it will just be -3 plus 5, so 2. Good. So I got y equals 1. That goes with this one up here. So, okay. So, if you use this one, when you double check, you should double check with this one to make sure, okay, this does go through both points, so we should expect them. The only change I would make is I wouldn't put y, I would just put f of x. Same thing over here. I wouldn't put y, just put f of x, right? Y is the same thing as f of x. Okay, looking at number 3, look, what is the rate of change for women's median income between 1960 and 1990? So again, another rate of change, another slope problem, another rise over run, another delta y, delta x problem. So our x's are usually going to be our time. So when we're talking about like social data, like looking at women's median income over time, our x is usually going to, our x, so our left and right, is usually going to be our time, right? How do things change over time? So our x values are going to be the time, and then the y value is going to be the women's income, median income. So here we would have 1990, right? Because that comes after 1960. So we would have 1990 minus 1960, and then this one would just correspond to the median women income for 1990, and this one would correspond to the women's median income for 1960. And then you just simplify and find the rate of change. Okay, let's look at 2.2. Okay, so we have calculated the average rate of change of f of x. So this one, calculating the average rate of change, is exactly the same as this. Exact same thing. We want to find the slope. It might not be for this function, right? If I block this off, these two problems are nearly identical. The only thing is they don't give you the y value. They give you the x value, right? Your x1 and x2, but they don't give you the y value for each one. How do I find that? I just plug it in. I just plug it in to each one, and I'm going to say, let's see. So I'm going to claim f of -1. All right, I'm going to plug in my y value. I'm going to claim that this is -11. Okay, and then if I plug in 3, f of 3 is also going to be -11. Okay, I want you guys to double check this. No. Double check. Okay, so I want you to double check these two solutions. Or so if you plug in -1 into this function, I should be getting y1. So then this is going to be my x1, y1. This is going to be my x2, y2. So -1, -11, 3, -11. Okay, finding the delta x over delta y, right? This is my rate of change, average rate of change. We will plug it in we will get negative 11 minus negative 11 minus negative 11, 3 minus negative 1, and I get 0 over 4, which is 0. Kind of suspect. So here, I'm not sure exactly how the graph looks like, but at negative 1, we have this point. Let's say this is negative 11. And then as I go to 4, it is also negative 11. That's what this is kind of saying. So if I look at this, if I draw a line between these, it's saying that my slope between these 2 points is 0. It's saying that as I go from negative 11, my average rate of change is 0. So meaning I didn't go up or down. I went up, but then I went back down the same amount. So the average difference in my height is going to be 0. And that makes sense for a parabola, right? It's symmetric over some point, right? At some point, you're going to have to hit this exact same point again. And these 2 points will have an average rate of 0. So, okay, so what if I want to find the instantaneous rate of change? The instantaneous rate of change. So this, I don't think we've gone over limits formally. So the idea behind instantaneous rate of change is I focus on one point. I focus on one point. I focus on one point, and then I go a little bit to the left and a little bit to the right. So here, there was a typo in the quiz. It should be estimate the instantaneous rate of change of this at the point x equals negative 1. And this interval is wrong, so we're not going to use that one. But this was supposed to be a hint, and I think it kind of messed you guys up. But anyways, the point, so we focus on one point. What point am I focusing on? For this problem, I'm focusing on x equals negative 1/2. So I'm looking at negative 1/2. Let's plot it on our x-axis. So negative 1/2. Let's go a little bit to the left. So this is negative 1/2. This is going to be negative 2, and then over here we're going to have 0. If I want to go a little bit to the left, I'm going to pick the point negative 1.1. Okay, and if I go a little bit to the right, I'm going to pick the point negative 0.9. This is what our new interval is going to be. We're going to take the average rate of change, but not of a big interval, like from negative 1/2. That's 4 whole units of interval. Here, we're going to take a little tinier interval around this point, and we want to see, and then we're going to calculate the instantaneous rate of change by getting it at smaller and smaller intervals. Right? So let's think about why this works. So let's say we have this, and I want to find the point here, x equals 1. This isn't my parabola, by the way, but this is an example I want to. Let's see. If I take the average rate of change of this point and this point, we're going to have a line that goes straight, right? And we have a slope of equals 1. Oh, it's 0. If I make this interval smaller, if I make this interval from here to here, Now it looks like we're getting a slope, right? Okay, what if I get it even smaller? Something like this. So let's keep this point the same. And let's get an even smaller interval, right? We're getting smaller and smaller intervals. We're gonna get better and better accurate intervals. So this is what it means by finding the instantaneous rate of change. And if I get even smaller from here to here, and get even better one. So as we narrow into a single point, we're gonna get a better and better accurate representation of my slope at that specific point. And when you take calculus, this is what we're going to call our tangent line. We're going to be able to find tangents of a lot of different functions. But right now, it's good enough to use just small intervals. Okay, so let's do an extra problem. Let's do an extra problem. So let's say I have the same function. F of x is equal to negative x squared plus 2x minus 8. And I want to look at the instantaneous rate of change at x equals negative. Let's do negative 1/2. Right? So we are at negative 1/2. No, negative 1, my bad. And then I'm going to go a little bit to the left and a little bit to the right. So a little bit to the left is going to be negative 1.1. A little bit to the right, it's going to be negative 0.9. This is my new interval. Okay, if I plug this in, and I'm going to let you guys double check, negative 1.1, right, my x1, I'm going to get, let's see, I already did this one, negative 11.41. And this is going to be my y1. And if I plug in f of negative 0.9, I'm going to get negative 10.61. So this is my x2, y2. My instantaneous rate of change, my instantaneous, so quotations, because this is still average rate of change, but very smaller. So it is still a average rate of change, but for our purposes, it's enough to call it instantaneous because it is over a very tiny small interval. Our instantaneous rate of change, again, it's going to be delta y, delta x, but over this tiny interval. So my delta y is going to be negative 10.61 minus y1, so double negative 11.41 over negative 0.9 minus double negative 1.1. Plugging this in, let's see, what do I get? Oh, this is a fraction, so we're gonna do negative 10.61 double negative, so we're gonna do plus 11.41, and then the bottom negative 0.9 double negative plus 1.1, and I'm going to get a value of 4. So this means this is my instantaneous rate of change at let's see, it's gonna look 4, so we're gonna go 4 up, so it's gonna look something like this, okay. We will go over this in class, so if you have any questions, let me know or let Mr. Lampy know, but we are gonna let retakes, right? But I want you guys to work through these problems before you reattempt it, because the end goal is, again, we want you guys to understand what's going on. Okay. Yeah, any questions, let me know. I'll answer any questions. Okay.